Okay, class. So today, what we're going to do is we discuss the graph for the practical. Then we do the current electricity questions. Okay, that's our target today. Okay. Okay. So first, let's go through the picture. Okay. Some of you send me the graph. I just want to comment about the graph. I just comment about the graph. So normally graph will be 4 marks. Okay, it'll be 4 marks. Okay, this graph, the graph out of 4 marks, what I can say, 1 mark given for the title. Title for me not clear.
So is Sir sharing screen?
Yeah.
Is Sir sharing screen?
Oh, screen. Oh, screen not doesn't.
No, we don't see anything.
So I like you to inform me earlier. Okay, good. Can you see now?
Yeah.
Okay. Nicholas, so this is the graph I received. So let me give you the comment. Your title must be quantity and unit. This should be quantity and unit. So here, can't see clearly. So if you must have quantity and unit, and next is your scale. Scale is 9. This is what? Can't see. Let me expand this. 6, 7, 8. Oh, so by one by one. Okay, no problem. So this by one. Okay, accepted. Do one multiple of 3. Yeah. So 1 is fine. 1, 2, 3 is okay. Your x-axis is 4.8, 1.5, 3.5. Is it? It's okay. So you got your scale only can be given mark. They check the how much is spreads. You see the spreading here. I minimize it. Okay, the spreading they're going to check. This is the first point. This is the last point, right? Oh, yeah, last point is here. Last point here. So first point is here. The last point is here. Is spread by how many boxes? From here, 1, 2, 3, 4, 5. So spread by 5. But total given, I think, is about 8. You got 4, another 4, 8. So 8 spread 5. So x direction, your spreading is fine. Your y direction spread a lot, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, around 11. These 11 boxes also partially was the point, but the entire box is included. So 11. So you get the scale mark. So this one, you get the scale mark. You get the title mark. And the cross, your best fit line. Your best fit line. They're going to check 1 point up, 1 point down, 2 point. I think this is down. Okay, now final. Okay, 2 point down, 1 point up, accepted. 3 point down, 1 point up, not accepted. Okay, if down and up you have points, and the differences in the down and up, the number of points must be 1. Cannot be more than 1. The differences. Down 2, up 1, accepted. Down 1, up nothing, accepted. Okay, down 2, up nothing, no mark. Okay, so up and down coordinates which does not pass through the line must have differences only 1, cannot be more than that. So this case, the graph is good. So you get 1 mark for the best fit line.
Sir,
Yeah.
if like two dots are above, but that is because of, well, for limit of proportionality, should we like ignore it, or we just like connect it also
Uh,
to best fit?
best fit. Let me go to the. Okay. You see what? You see there is a line. There is a line. So you got. You see what? 2 points up. Is it?
Yeah, but it's like 0.1 up a bit. Yeah,
Okay, little. So, but both are up.
yeah, both are above.
The other 4 is on the line.
Yeah,
Okay, the other 4 on the line. So what's your question?
yeah. So should we like make a best fit so that those one of those 2 points fit, or like well,
Or if you like this, what you have to do, you have to change your best fit line. You have to change your best fit line. You have to, how do you going should change it? Up. You have to put it, I think here or here. If you go up like this, you have to go such that you must go like this,
or
such
such that two are above,
2
two are
up or
below?
3 down can.
Uh,
So you can't have, in this case, you draw 4, but you're ignoring these 2. So 2 up, nothing is down. So best fit, you get wrong.
okay.
Okay. You're going to draw a best fit line. So you have to try to make it balance both sides. One differences is fine. Okay. So in this case, I think you have to cross the line, no choice, because we thought 4 is nicely placed. These 2 up, so you have to tilt it up a little so that 2 down, 2 up, maybe up here. Okay, good. So another one thing I never tell you yesterday is this part. Uh, this part, this dot. This dot, right? This dot you have to make it very small. The cross you make, must be just one box. The one small box, the one small box. The amount of dot size you are making should be very small to the one small box. You see, here got 10 boxes, right? 10 small boxes. 10 small boxes. Your X, the cross, must be only size of one small box. Okay. I never told you that. So the cross must be one small box, and you can draw the triangle. Draw the triangle. Draw the triangle to show where and where you take the points to calculate the gradient. Draw the triangle. Okay. Draw the triangle. If you never draw triangle, it's okay, but difficulty for the examiner to find which point you are taking. Better you draw the triangle. Easier for them to find which point you are taking. The triangle have to be at least more than the half line. In this case, I cannot identify because I don't know which point you took for the gradient. Okay, so overall, I think this one is getting 4 out of 4. Assuming that the point you took is quite far away for the gradient. Okay. Okay, any questions? No? Okay, this is another graph. This graph, I'm worried is about, okay, scale correct. Scale is spreaded 2 centimeter, you give your scale number. Don't go more than that. Okay, 2 boxes, you must give a scale. If you go more than 2 boxes, you give a scale here, you're going to lose mark. Every 2 boxes must have scale. Okay, so here the scale just nice, good. And the spreading I'm worried about. Spreading must be half of the box. Horizontally is 1, 2, 3, 4, 5. Okay, good. Vertically, the point started here, so it's 1, 2, 3, 4, 5, 6. Okay, just nice. So escape from the limit. Good. So you get mark for the scale. Okay. Hope the scale is not multiple of this what 3, 4. This is can't see. I think 3, 4, not multiple of 3. You get mark. Down here, cannot see. 4.5. This is what? I think it's multiple of 5. 4.5. I think it's multiple, not multiple, all looks 4. So as long as never multiple of 3, you get mark for the scale. Because your point really spreaded, as long as it's not multiple 3, you get a scale mark, 1 mark for that, 1 mark for the title and the gradient. And the best fit line, how many up? 2 up, 2 is up, nothing is down. Yeah. So you lose your best fit mark. Best fit line, this is wrong. 2 up, nothing down. Okay, so what you should do for this case, I think you must put a ruler little up so that it try to pass through like this here. In between. Little up. You have to put this point down. You have to move this up little. Okay. What I mean is, I think you have to move this point up here. Make the line something like this, maybe. Sorry, something like this. Little up until like one of them down. One down, one up. Accepted. 2 up, best fit. You lose 1 mark. Okay, minus 1 mark. So out of 4, you only get 3 out of 4 in this case. Best fit is wrong. Okay. Okay, this is how it goes. I hope you can evaluate with others. Let me check more graphs. Okay, this one, can we give 4 marks? Is it best fit line correct? I think the problem is the best fit line. Can we give mark for the best fit line? 1 down. Anything up? Nothing is up. Oh, this is good. I think this little up. Okay, good. So 1 down, 1 up, little is fine. So it's best, you get the best fit mark for this. Okay. Other than that, this is fine. So 20, 40, multiple of 20 is fine. For okay, yeah, good. Spreading good. So you get 4 marks for this. This 4 marks. Okay. Okay, now next. This one just now. 5th one. Okay, this is another one. Okay, best fit. Can you give mark? Okay, 1, 2, and 3 up. 1, only 1 down, but 3 up. 1, 2, 3 is up. Only 1 down. So you won't get best fit mark. You must make another 1 down. Okay, you must make, I think from here, you have to put the ruler maybe somewhere like this, a little up here. Okay, we have 1 point, 2, 3. Yeah. I think you need to pass through this point. So 1 up, 1 down. Yeah, 2 up, 1 down. Okay. But this is 3 up, 1 down. No best fit mark. Okay, class. So I hope you have some idea. Okay. So next round, please try to do the graph part. Graph 4 marks. Table 10 mark. Okay, so table more important. But of course, graph, we're checking how well you utilize the graph paper. The 4 marks given is what? For the title and the gradient, the triangle is like 1 mark. The scale spread it properly, you get 1 mark. 6 points transferred correctly, 1 mark. And best fit line, 1 mark. Okay, so check these 4 properties always. Again, what is that? The title and the gradient, or like together like 1 mark. The scale, not multiple of 3, and spreads at least half of the box, 1 mark. The best fit line, 1 mark. And 6 points has been transferred correctly, 1 mark. Okay. Any questions from here? Before we go to the current electricity passes. No questions, Okay, good. We go back to the passia now, Okay, class. Am I recording? Recording, okay. Two of them unable to attend. Okay, Praveen, can you put it into the group? Ask them to join in the Tuesday, what do you call? The Wednesday. You join in which group just now? Can you put in the group? Ask them to join.
Okay, sir.
Thanks. Okay, because sorry, I think the 10 o'clock was cancelled. I forgot that. I need to set it back. Okay. Let's go back to the questions. Okay, the current electricity Okay, we're done with the topic. So I believe you've done some questions. Anyone have any question from these questions? If not, I select some, the one difficult one, or the one your seniors got problem. Any questions? Anyone tried? So no one tried, eh? Okay, I hope you tried. Okay, let me select the questions, eh? Okay. So far what we learned in this topic, just a small recap before we do the questions. What we learned from this topic, everything I think about the same. Current is what? Q over T. Then current, what is another formula? NEA, VD, drift velocity. The derivations have to know. Then voltage is what? Potential difference. Work done per unit charge. Okay. Then what else? Then EMF. EMF is what? Again, other form of energy change to electrical energy per unit charge. Then you learn what? Then learn V equals to IR. Actually, the resistance formula, V over I, the Ohm's law. Then Ohm's law, you need to know all the VI graph and I versus V graph for 3 devices. What is that? For diode, lamp, then what else? Your fixed resistor. You have to know V versus I and I versus V. A thermistor out of the syllabus, but sometimes I think they might ask. Okay, then after V, R equals to V over I, then something new we talk about is the efficiency, the internal resistance and the efficiency. The efficiency of the circuit is R over R plus R. Then another one thing, the last one we learned is the power dissipated across the external load versus R is a curve, and the maximum achieved when the R is same as R. Okay, it's all what you learn. Okay, based on that, okay, let's go question 32. Now this is page 4, question 32. Get me the answer. One minute for you. You can, as usual, WhatsApp me your answer. Okay. The EMF is 9 volt. The reading on the I resistance voltmeter is 7.5 volt. The resistance is 15 ohm. What is the current I? How much is the current flow here? So what formula means you must recall? Whenever there is a EMF, then I think you need to think about E equals to I capital R plus I small r. Okay. So looking for what? Looking for the I. Looking for the I, the same I. EMF, do you know? EMF is 9 volt. R, do you know? Capital R?
Teacher B.
B, 0.5 ampere. Okay, good. So all of you got B, Okay, let's see. So resistance is how much? Resistance is 15 ohm. Internal resistance, we don't know. We don't know the internal resistance also. Okay. We don't know internal resistance also. Okay, 2 of you saying B. What's also B? Okay, so we don't know the internal resistance. So we have 2 unknown here. We don't know the I, we don't know the internal resistance, but we know the terminal potential. IR is 7.5. So IR we know is 7.5. So I think we just use V equals to IR only. The terminal PD is enough. Terminal PD is 7.5. I we don't know. The external load is 15 ohm. Yes, then you give the current. So it's 0.5 ampere. Okay.
So the EMF formula this time doesn't work because we have two unknown. We don't know the current, we don't know the internal resistance. So this 9 volt is extra information, you never use it. Sometimes Cambridge they give extra information. Very rare, but they do sometimes. Okay. So good, those who got B is the answer, 0.5. Okay. Stop me if you are asking, if you want any question, you have any questions, Okay, next. It's going to be a voltage. Oh, let me stop this. Okay, 31. Juno 431. Give me the answer. Okay, WhatsApp me the answer as usual. Hope everyone give me the same answer. Which formula to be used? Two wires made of the same material. It means the resistivity same, the rho same. And if the same length are connected in parallel to the same voltage supply. Same length and they are parallel, okay? And the same voltage supply. Wire P has a diameter of 2 mm. Wire Q has a diameter of 1 mm. Wire P is more thicker than the Q. Diameter is a culprit. Put the diameter into area. Okay. Put in area.
A.
So getting A. So let's see the others. You want to find current, ratio of current. So what is same? The resistivity is same. V equals to IR. R is different. R is different. Yeah. So P RP must be same as IQ RQ. So we are looking for IP over IQ should be same as RQ over RP. RP. Yes. So R changed to what? Rho L over A of P multiplied by A over rho L of sorry, this PQ, this Q, this P. Okay. So rho L for both same. So cut. So IP over IQ is IP over IQ is AP over AQ. Correct, right? AP over IQ, RQ, RP, RQ, R rho L AP. So AP over AQ lah. Yeah, okay. AP over AQ. So AP is how much? AP is 104.4. 104.4. Guys, is it 104 or 4? Current will improve.
Sorry, yeah.
Should be 4, right?
Oh.
So AP over AQ should be 4 to 1. 4 to 1. So it should be 4. Yeah. So we start from the voltage same. Voltage of VP, VQ same. Then rho L over A need to be brought in. But diameter is a culprit. You have to change to diameter. This because this diameter is 1 mm. This is diameter 2 mm. Should we put the 1 mm as A, the 2 mm is 4A. Because 2 squared what? Because area is pi d over 2 squared. When the d double, where is it? Yeah. So when the d is double, the area becomes 4 times bigger. That's a trap. Okay. 1 mm is area A, 2 mm, the area will be 4A. 3 mm, we assume like is 3 squared, it's 9A, and so on. So then should be 4. Answer should be short. So those who got 4, good. Okay. Any question from this 31? Okay, so let me go for another question. Okay, 33. Page 10, 33. Give me the answer. Okay, so what's the answer? The terminal voltage of the battery is observed to fall when the battery supplies a current to an external resistor. What quantities are needed to calculate the fall in voltage? Fall in voltage. So E equals to VR plus I small r. Okay. So this is your EMF. Let's say you purchase a battery and the battery plays a label of 1.5 volt. But when you connect the voltmeter and the reading may be 1.4 volt, so 1.4 volt is a terminal PD, but the EMF is 1.5 volt. The EMF is 1.5 volt. But when it comes out, the voltage become 1.4 volt. So 0.14 volt has been dropped. There is a drop in voltage. It's capable to produce 1.5 volt, but when it comes out, it's 1.14 because the internal resistance used up some voltage, and that's called drop. So what quantity needed to calculate the fall in voltage? Who's the fall in voltage? The internal resistance voltage, and this is the fall in voltage. This is the fall in voltage. So how do you calculate this fall in voltage? What are the measurements you need to take?
The current and battery internal resistance.
Yeah, C is direct already. C should be the correct one. A battery EMF and the internal resistance. I don't think so. You know EMF, you know internal resistance. How are you going to find current without the terminal PD? You need to know the terminal PD. The battery EMF and the current also cannot. Battery EMF and the current also cannot because you need to know the internal resistance. So C is the best answer. Okay. Okay, 34. Next question. Give me the answer. So what is the current between X and Y? The voltage between X and Y is 20 volt. The time taken for the charge carrier to move from X to Y is 15 seconds. Time given, voltage given. The energy of the charge carrier changes by 12 joule. 12 joule of energy has been transferred. What is the current between X and Y?
Is it A?
A, okay, let's see, is it, all of you got 0.04 ampere? How do you calculate? Because current is what? Current is rate of flow of charge, rate of flow of charge. So time, is 15 seconds. We need to know the charge. To get the charge, you know the voltage, you know the energy. So we use the voltage formula. Voltage is what? The amount of energy transferred per unit charge. Okay. So voltage was supplied was 20 volt, and the energy we know is 12 joule of energy has been transferred. So we know how much of energy, charge has been moved out. So the charge is found to be how much? Is 12 over 20. 12 over 20. So we put here is 12 over 20, or in other words, is 6 over 10. So is 6 over 10 is 0.6. 0.6 divided by 15 will give you the current. Okay. So 205. So we got 0.04. Okay, good. So those who got this idea, good. So you must think about current, Q over T, rate of flow of charge, time, charge you don't know. The charge can be obtained from voltage. Voltage is the amount of energy transfer per unit charge. Energy transfer, they already told, is 12 joule. So we can find how much of charge has been transferred. Answer is A. Okay. Any questions so far? Okay. Okay, let's move on to more questions. Okay, 31, November 4. Okay, so anyone can give me the answer? The usual definition we use to define potential difference is not there. So you need to use the best answer. Okay, the actual definition is not in the option.
B.
So you go for B.
I think.
B, boy, yeah. Okay, let's see. Okay, we know potential difference is what? Energy per unit charge, the amount of energy transferred, the amount of electrical energy converted to other form energy per unit charge. It's not here. Okay, so first, let's go one by one. First, force required to move a unit positive charge between the point. Force required to move a unit charge. That means, according to AA, they say the voltage is force per unit charge. Force per unit charge is actually Newton per coulomb. Newton per coulomb. Voltage, what is the unit? It's joule per coulomb, which we call it as volt. The unit for volt is joule per coulomb. So the first quantity, although you never recognize what is force per unit charge, but according to mathematically, force divided by charge give a Newton per coulomb. So according to the unit homogeneity, I think A couldn't be the answer. Cannot be the answer because unit is not joule per coulomb. So A is out. B, the ratio of energy dissipated between the points to the current. The ratio of energy dissipated. The ratio of energy, they say is ratio energy to the current. So can you create the formula for the B? B, the formula is what? According to them, they said the B, they said is the energy over the current. Can it be the answer? So energy is joule, current is ampere. So the unit for this formula is joule per ampere. But the voltage should be joule per coulomb. So again, and on the basis of homogeneity, the unit cannot be joule per ampere for volt. So B cannot be the answer. Okay. So check which one most suitable. Go for the C. Could be the C answer. The ratio of power dissipated between the points to the current. They say voltage is the ratio of power to the current. This makes sense, right? You know this is formula, right? P equals to IV, right? Okay, we bring the I to the other side, it's P equals to IV. So C is the correct answer. Okay, let's recheck. We go for D first. The ratio of power dissipated between the points to the charge. D equation is the voltage, they say, is P over Q. Oh, cannot be, cannot be. Not power over charge, should be energy over charge. Energy over charge, then D is correct. So the best option here for voltage is C. But in exam, if it comes out, they ask you to define what is voltage. You don't go and define with C. The definition for potential difference is what? The amount of electrical energy converted to other form of energy per unit charge. That's the definition for potential difference. But for this objective question, we have to choose the best answer. The best answer is C. Okay, the best answer. But that's not a perfect one. If this question asks in structured question, don't go and write C. You won't get mark. The energy per unit charge is the best answer. Okay. Any part you don't understand? Okay, and
Teacher.
Yeah.
Can I define voltage as work done to transfer 1 unit of charge across 2 points?
Yeah, can accepted. But when it comes to EMF and PD, they ask you to distinguish differences. You better stick with the energy. The EMF is other form change to electrical per unit charge. PD is electrical to other form per unit charge. Okay, more convenient, more term, better, more convenient. I think work per unit charge also easier to define. Okay, if they ask what is PD, you say the amount of work done to transfer per unit column of charge. Accepted too, it's not wrong. Okay, but I prefer energy change. Okay, because later they ask you to distinguish between the EMF and PD, easy for you to distinguish it. Okay.
Okay.
Okay, 33. Page 12, question 33. Okay, 1 minute again. Carefully you analyze the question, come on. Okay, class, put in your mind, diameter is a trap, change to area. Okay, D is A means 2D is 4A. Change to area. We just, at the beginning itself, we state D is like area A, 2D is like 4A. Because this is a ratio, so you're going to cancel. Okay, anyone got the answer? So potential difference. We applied between the ends of a wire of diameter D and L. 2V applied for the 2D, 2L. Oh. One wire diameter is D and L, and the voltage is V. The voltage applied is V. Another wire was 2D, 2L, longer. Okay, and the voltage applied is 2V. It's 2V. 2D, 2L. Okay, they're asking what is the current flow here? What is the current here? What is the current here ratio? Maybe I put I1 to I2, right? Assume the temperature, the wire remains constant. What do you want? What is the current when the potential? Oh, sorry. The current flow at the one is I. One is I. What is the current flow in I2? Okay, the one current in I2. Okay, what formula comes to your mind to calculate this? You got diameter given, length given, voltage given. They're asking for current. So I think you have to go for ratio. What is same for both of them? What is same for both wires? You need to link the I with I2. So you need to make an equation. What is same for both of them? The
resistivity.
The resistivity is the same. That's the clue. You find what is same. So we make the resistivity of the first one must be same as the resistivity for the second material because it's made of the same material. This is same material. They never say it's the same material. Same material. Same material. So therefore from here we need to bring in all the I. So how to get resistivity? Resistivity actually V equals to IR. So R equals to V over I. So what is that? Rho L over A equals to V over I. So rho is, write the rho. Rho is AV over IL. This is the formula, right? AV over IL is the resistivity. Okay, from the voltage, we get the resistivity. Okay, good. So now put the values. The first one, rho 1 is area is A, B is V, current is I, length is L. For the rho 2, A is how many A? 2 diameter one. So it could be for A, V must be how much? V is 2V. And I, we are looking for that I2, and L is 2L. Okay, that's it. Okay. So now find the I2. With the I2, the subject, you get the number. So here all AV cancels, so you got 2, 8, or 2, 4. So how much you get? I think you get 4I. Okay. Okay, all of you got 4I? Okay, 4I, right? The current here should flow is I2 must be 4I. 4I. The clue is the resistivity must be the same. But another problem is you can't simply use rho L over A. You can't use R L over A because resistance not provided. They give length and diameter. So the R need to expand to, rho L over A, and V over I need to be involved. V over I need to be involved. So you get the formula for rho. So it should be AV over IL. This little work to be done. Then you get 4I. Okay, any question from this question 33? Okay, the trap is the diameter always. Please change to area. Yeah, let me see more questions. Okay. Okay, 33, question 33. June 05, question 33. Come on, class, this time, everyone get the same answer. Okay, this all are very common, very common in Cambridge. They say this double, this become R, this quarter. What is the final answer? Okay, so you must create improve the skill to do these kind of questions. Not only this topic, in all the topics. Okay. So how do you do this? A cylindrical piece of soft electrical conducting material has a resistance of R. It is rolled out, so the length is double. Oh, it's 2L. L become 2L, but the volume stays constant, or the volume of the wire stays constant. That means volume stays constant means area become how many times? The original wire, we create the symbol. The area is A, the length is L. Therefore, you get R, let's say. Okay, resistance R, so rho L over A. Okay, the second one, they say the length become double. Now the length is 2L. But the volume kept same. The volume of the wire here and the volume of the wire here is the same. So A become how many times? Smaller, right? Because that means AL is the volume. So when the L become 2L, area have to be A over 2, right? Have to be A over 2, then the same volume one. So the area going to drop to A over 2. The area drop, the length become 2L. So what is the new resistance? What is the new resistance value? New resistance, rho L over A, the formula. We substitute all the information, rho is rho, same rho, but L become 2L. Area was become A over 2. So therefore, you get 4 rho L over A. It's 4 rho L over A. But rho L over A is the R. So it's going to be how much? It's going to be 4R. It's going to be 4R. So answer is, should be D. Okay, class. So, any questions from here? Questions,
No.
Okay. Last question. Okay, then we stop. Okay. There is one question I need to ask you. This one. Okay. Question 19, page 1934. At which point the resistance is the smallest? So, how do you find resistance is the smallest? Judges, please submit your answer. Which answer do you think? A, B, C, D, which one? This I versus V graph. Okay, this I versus V graph. So how do you find for I versus V graph, the reciprocal of the gradient, the straight line gradient, the straight line, not the tangent, not the tangent gradient. The straight line gradient pass through origin. Okay, reciprocal of the gradient of the straight line gradient. The straight line is the straight line pass through origin. The reciprocal of the gradient will give you the resistance. So you draw a line from 0 to A. This is this line for 0 to A. You get this gradient. Okay, gradient. Let's say gradient you got, let's say 2. That means the resistance of A is 1 over the gradient. So 1 over 2 ohm, for example. So what is the resistance of B will be? You draw a line from origin B, sorry, should be B, B, and draw the line for the C. Draw the line for D. Use your ruler. I can't draw nicely. Okay, tell me. The resistance is 1 over the gradient. The question asking the smallest resistance. To get the smallest resistance, the gradient should be the highest. So which line has the greatest gradient? A, B, C, D. Which has the greatest gradient? Of course, the C has the greatest gradient. Okay, the C has the greatest gradient. Therefore, the resistance of C will be the lowest. Okay, so draw a straight line, not the tangent. Draw the straight line from zero, from origin to that point. That gradient is used to find the resistance at that point. Okay, any problem from this question?
No.
Okay, class. Good. I think not many of you done this paper yet. Okay, I want you to give a try. Every topic you need to give a try. So the next class, maybe the first 15 minutes, I ask you any questions if there is any. If you don't have, then we will be continuing with another topic. Okay, so the next topic is another challenging topic in AS. Okay, DC circuit. Okay, prepare for it for tomorrow. But before we start that topic, 15 minutes left for this, if you have any questions. Okay, so today, please go through this question. Please go through the questions. Get the one you have problem. Okay. So if you don't have any questions, I stop here.
Sir.
Yeah.
What is P maximum when the external resistance is equals to the internal resistance?
Oh, the differentiation. You tried the differentiation?
Yes, but how does it work in like real life?
Or real life, let's say your house, let's say maybe you have a light bulb, okay, a light bulb, external light bulb for the car. Maybe car breakdown, you want to use a light bulb. You have a battery in the car, a battery connected to the light bulb. Okay, you want to get the maximum brightness for the light bulb. Okay, maximum brightness for the light bulb. You know the resistance in the light bulb. Let's say the resistance in the light bulb, let's say is 2 ohm. Okay, the battery internal resistance must be 2 ohm. Then you get the maximum brightness. You will get the maximum brightness. So yeah, so this all are manufacturing limitation. When a battery is made 2 ohm, the light bulb will be made at a different resistance light bulb. Use the light bulb with the 2 ohm resistance of light bulb. The light bulb will have a maximum brightness. The maximum power will be dissipated. Okay. So, but normally when you purchase a battery, it will have its own internal resistance. You can't change it. You buy a light bulb from the shops. Okay. Okay. So, but the brightness you're going to get, from the light bulb is not actually maximum, because maybe the power rated in that light bulb maybe is 20 watts. Okay, 20 watts, and the voltage maybe let's say is 20 volt. Okay, so P equals to V squared over R. You find the resistance of this light bulb. We don't know what is the internal resistance of the power source. If the both are same, then you get the maximum power. Okay, so not every day you will achieve maximum power, because the 2 ohm internal resistance and the light bulb resistance is totally in the manufacturer's hand, Okay, so you want to get the maximum brightness, you choose a light bulb which has a power rating, the watt and the voltage value. You calculate the resistance. The resistance must matches with the internal resistance of the battery. Then you fix in the circuit. Then that will give the maximum power, very high brightness. Okay, so that's a fact to remember. Fact to remember. That's it. So in exam, they will ask you, like for example, you see the graph here. The earlier there is one graph. This is the graph. See this graph? This is the power versus voltage. This is power and voltage. Voltage across which resistance? Voltage across this resistance, P versus IV. Or this is a different graph. Ours is P versus R. Okay. Yes. So in your daily real life, you want to have a maximum power. You need to know what is the power supply internal resistance. Then you buy a power light bulb with the same resistance of the internal resistance of the power supply. Then you get the maximum brightness. But we not daily life. We're not going to do that, because it's not in your hand. Only thing you can do is you need to calculate every time the light bulb, check the resistance, what resistance matches with the internal resistance. You also don't know what is the internal resistance of the power supply. So very difficult to achieve. It's in the manufacturer's hand.
Okay.
Okay, class. So any other questions? Okay, thanks. I think time's up. So I see you then tomorrow.